Hello, this is Dr. Pin. Today I'd like to share with you uh, something about algebra. Like as homeschooling parents, um, you have helped the kids from kindergarten through elementary school, and then once they get into algebra, you probably just throw your hands up and say, "I don't know. I have no idea what they are, and so I cannot help you." And unfortunately, this is due how algebra was taught in America. And algebra actually is not that hard once you understand what it is. So I'm kind of give example why people think algebra is hard. Well, tell you a little story. I was growing up in China, and then I went to Canada for my graduate school, and that's where in Canada, I learned how to play soccer, and I really enjoyed it. But you may not know this. Outside United States, soccer is called football, and it's a very appropriate because it's a sports that you play the ball with your feet, and it's only in this country that uh, we call we call it soccer, and because we have something called football already, um, and um, as a matter of fact, in China, the way soccer is translated as football. I mean, you use your feet, and the football we know here is translated as uh, olive fruit shaped ball, that's the shape of the ball. So when I came to the United States, when I first actually got exposed to football, and I was very confused because I was thinking about it's football, you play the ball with your feet, but it's not the case when you watch a football game. And actually, it's only most players, they just grab it and they just run with it. And you actually you can bump into each other and all that. And that kind of like bumping into each other, and that was considered fouls in soccer, but not in football. And but I was thinking about really from my experience with soccer, and that's how I get confused. But once I get understand the rules, and then everything become easy, become clear, and that's actually uh, the same reason why algebra is hard, because what we learn in elementary school and those kind of math is called arithmetic. Arithmetic deal with numbers. Uh, but once we start going to algebra, that's a totally different game. And so the rules are different. So if you just think as the rules in algebra, and then you get introduced no the arithmetics, and now you get thrown into this algebra, you get totally confused, and especially when you are not being told that um, we have switched. We are talking about a different game, different type of the game, and once you understand it's different, and there's a rule based on that, then actually algebra will make sense to you. And as grown-ups, you actually would appreciate more uh, than the, the young kids. Okay, so with that, we can looking at what is algebra. Well, first of all, algebra is a mathematical language, is to understand the natural world around us. And Galileo Galilei, that's one of my favorite physicists, and he has this famous uh, saying about math. He said that mathematics is the language uh, uh, with which God has written the universe. And it does make sense because that's how we understand the natural world, the fit, all the things, how the planet moves, and how things react, and pretty much everything around us. We have to use math to help us to understand it. And algebra is a branch of math, and it's actually had very simple a set of simple rules. But what makes algebra special is that we're going to play with symbols, and the reason why we play with symbols is because we can derive formulas that will help us understand the natural world and also help us to solve problems that we encounter in the natural world. And for me as a Christian, actually, I was grew up in China, so I was raised as atheist. But when I was got interested in math, and later on, when I was doing my PhD uh, in electrical engineering, and I can see that the actually math point us to God's designs in nature and God's creation. It's very hard to explain that from the atheist worldview, because we do see designs, we do see patterns. Things are not, we see the orders in the nature. And if there is order, there's design, there must be a lawgiver and there must be a designer. So that's how I was um, um, led into uh, um, believing there is a God and God created all that. Okay, so I'm going to give a couple examples and to kind of help you to understand algebra. Okay, I'm just showing this two famous formulas. One is F equal to ma. That is the second law. F equal to ma is the second law, Newton's second law. This tells us when we see objects in the natural world, and we see the movement, and this explains to us that if something is moving at increasing speed, then there must be a force on that object. But if that object it just moves in a constant speed, then there is no force on that. So we use that really can explain a lot from many things happening. And of course, the second one is Einstein's formula is E equal to mc squared. And that kind of show us that E is energy, M is matter, and C is speed of light. And that kind of show us matter and energy, they are related. And it also show us there are a lot of energy in matters. And just think uh, how heavy we are, or then you times the speed of light and square. We have lots energies. So the energies that in our body, and it's um, good enough actually to destroy the whole city, maybe more than that. Okay, but the formula is so simple. And when Einstein was asked why do you believe your formula is correct? Now his answer is, isn't it beautiful? Well, he saw the beauty in that E equal to mc squared. It's pretty, okay? And so using the form uh, letters, using symbols really help us to understand the world around us. Okay, so I'm going to give you a couple examples how we use algebra to understand things. Well, first of all, can go back a little bit. When we're dealing with elementary school math, those are called arithmetics. We're dealing with we're concerned about the values. We'll say, okay, 4 times 4 is 16, and 7 times 9 is 63. Well, we want to know the value. But once we got into algebra, uh, even though we still need to know the value, but we're more interested in the pattern, in the general rules. We call that laws. That the numbers, the properties of numbers, how they are, what kind of rules that they obey. So again, in arithmetics, the elementary school math, we're interested in the value, but in algebra, we are more interested in the properties of those numbers. So I'll give you a couple examples here. One thing you can see here, 2 plus 2 we know is 2 times 2, and 3 plus 3 is 2 times 3, and 5 plus 5 is 2 times 5, which makes sense because that's what when we add to what multiplication means. It just means two, like in this case, two groups of two. It is one group, two group, or this is 2 times 3 is two groups of 3, maybe two groups of 3 apples or two groups of 3 bananas, doesn't matter. It's just two groups of 3 something. And the here, 2 times 5 is two groups of 5 something. Of course, they have to be the same thing when you can be able to add. So you can add 5 bananas plus another 5 bananas, like at 10 bananas, but you cannot add 5 apples with 5 bananas. So, but what we see here is this interesting property that relate addition and multiplication. If the same number add is basically just 2 times that number, okay, so we see that that's a property of numbers, and that is true for all numbers, not just 2, 3, 5. It could be 7 or 100, 1,000. They all follow the same pattern. So therefore, we can either use English, say, okay, when you add the same thing, then it's equivalent to 2 times of the number of that thing. But in algebra, we can easily using symbols to express that. Here, you can see that a plus a is equal to 2a. What does that say? It just says that as long as we have the numbers are the same value, then it is always twice of that number. And so that includes all the numbers. Just very simple expression that can show us the properties of numbers. And whether or not to use A or use B or use X, that doesn't matter. So A plus A equal 2A, or B plus B equal 2B, which means 2 times B when we start 2B, or X plus X is 2X, it means the same thing. Okay, but here again, we are interested in the properties of numbers. Okay, and then we show another example. Where you see here, we see that 3 plus 2 is basically 2 plus 3. Both are 5. 4 plus 7 is 7 plus 4. And that actually is true for all numbers, which says that when you add two numbers, the order really doesn't matter. But how do we say that in terms, in the language of the algebra? Well, we can simply say, you write like this: A plus B equal to B plus A. Okay, that just shows all that. So that's basically what we're interested. You see, we use symbols, we can explain the properties of not only numbers, but also the property of addition, which we call operator. Like operators in elementary school is addition, subtraction, multiplication, and division. But this shows that for this addition operator, then really doesn't matter the order. Okay, so I'm going to show one more examples. And here, what we say here, what is 3x plus 4x? Now, when I teach my student, they're always asking, what's the value of x? And I tell them, well, it really doesn't matter in this case, because we're not interested in the value of the answer. We're interested the rules or the patterns that we see. Well, what 3x plus 4x, what that mean? You can think of, if we have 3 apples plus 4 apples, we got 7 apples. Or 3 bananas plus 4 bananas, we got 7 bananas. Well, as long as we're talking about the same thing, then 3, in this case, we don't care about what number x is. X can be any number, but as long as we're adding the same number together, you can think about this as 3 groups of x, and this is 4 groups x. Then the answer has to be 7 group x. And that's pretty much it. I mean, that's what the kind of the language of algebra, which can help us really to not only explain the properties of numbers, but also allow us to do many amazing things. So I'm going to show you. Oh, there's another thing my student will ask. I mean, probably get confused. Why we have, what's it means by variables? Why do we use variables? Well, first of all, we actually use variables in our daily life, in just in any language, and we use that to explain, to help us to explain things. So here, I like to use this sentence to explain it. Is you can see that it is dark outside. I saw a cat. It is white cat. It sits on top of my red car. It is new car. So now in very simple paragraph, we see this. We see it. We say it 4 times, the same letter, same word, but its meaning get changed. When this it means the weather, it means what's going on outside, maybe the day of the time of day. And then on this it means the one in front of that is the cat. And of course, this it is also means the cat. And then, but this it means my car is my new car. And you can see that even though the same letter, but it changes the meanings according to the context. And so this basically is what a variable is. It same word, but its meaning got changed. Another way you can look at the variable is that your mailbox, it's the same mailbox. It's sitting there, I don't know for how long, like my mailbox, my previous mailbox that was like 20 years old until I changed it, just well, a couple of years ago. So you see the same mailbox. It does not change, but what's inside the mailbox changes pretty much every day. So what's the content inside changes every day. So that is what variable is kind of like a placeholder, and its content changes depends on the context. Okay, so we use that in math to help us to find patterns and to help us to see the clues. And then we can also manipulate those variables, and so that we can either find a solution to a problem or we can derive formulas. Okay, I'm going to show you a couple examples kind of to help you understand that, why we use that. Now, here we see that when we have two even numbers, say 4 plus 6, the answer is 10. So the sum of two even numbers is even. Well, we could have 8 plus 12, that's 20. So we see another example that when you add two even numbers, the sum is even. But is that true for all numbers? Now, how can we prove that? Well, one thing you might think we just try all the numbers, but the problem with that, there are infinite number of numbers. So we won't be able to do that. Now, how do we use something to be able um, to handle that kind of infinity? And that's actually amazing thing about humans. Even though we are finite, we actually can think infinite. We can think about infinity, and actually we can handle some infinities, not all, but we can handle infinities in many ways. Okay, so how do we prove that? That the sum of any even number is even? Well, so first of all, we have to come up with a definition. It's kind of same thing when we write a sentence. We have to define our terms. Okay, so uh, what's a even number? Well, if you notice a even number, what that tells us? It tells us a even number has to have a factor of 2, which means a even number is 2 times another number. Whether or not that number is really doesn't matter in this case because we're interested in the properties of number. But a even number is it, we call that has a factor of 2, just like 2 times another number. Like 4 is 2 times 2, 6 is 2 times 3. So they all have a 2 there. Now, so we say, okay, two even numbers. We come up with A, that's 1. Then we have another one is B, which is 2 times M. Okay, M and N could be the same, could be different. And because since we are talking about any two, so N and M, they are uh, different, or could be the same. Doesn't matter. It's just like they increase all the possibilities. Okay, so now we have that. That's kind of basically we give a definition. And then what's the sum of two numbers? Well, A plus B is 2n plus 2m. And there is a rule in algebra. It says if you have common factors, we can move that out. That become 2m plus m. Well, what is m plus m? We don't know the value, but we know m plus m is just a number. Well, the sum, which is a plus b, is 2 times a number. That means it has a factor of 2. So therefore, by definition, a plus b is even. And now you see that. This is the power of use symbols. That just covers all scenarios. It covers all numbers. So I'm going to show you another example. We're talking about any two odd numbers. When we add them, the sum of any two odd numbers is also even. Okay, well, we have some examples. 3 plus 7, two odd numbers. That's 10, which is even. Or 5 plus 11 is 16. That's even. But how do we know that it is true for all numbers, or any odd numbers? Same thing, we're going to have to define an odd number. Well, it's pretty hard, might be hard to say it if you ask someone, or maybe just ask yourself, what is an odd number? Everybody knows what an odd number is, but it's hard to give a definition. But in algebra, odd number, the definition is pretty simple. An odd number is an even number, 2 times n plus 1. So 3 is 2 plus 1, 5 is 4 plus 1. Okay, That's pretty easy to define it. And then, by the way, actually in formal math, we actually write like that. It just means this is the definition. And B is defined as 2m plus 1. Well, what is A plus B then? Now it's the logic consequence of the definition is actually 2n plus 1 plus 2m plus 1. And that equal to 2m plus 2m. 1 plus 1 is just 2. And now we see 2 is a common factor. We can move 2 out, which is m plus 1. Now, m plus 1, we don't know what it is, what's the value, but we know it's a number. So therefore, a plus b is 2 times a number, which by definition, that's an even number. So we easily prove that the sum of any two odd numbers is also even. Okay. Now I'm going to give can share with you a little history of algebra, because that can help us to understand algebra. Well, algebra actually is known as algebra is actually in the is because this Persian mathematician, it's a long name, Muhammad ibn, I don't know how to really say that, Musa al-Khwarizmi, al-Khwarizmi. Yeah, I'm butcher it. Okay, but he was from 780 to 850 AD. So it's about more than now we have 2023. So you can think about that's about 1200 years ago. And he actually had called father of algebra is because he wrote a book. And the book is called, as translation goes, is the science of restoring and balancing. And we have this word is Algebra. And that word, when we got introduced to the Western world, it became called algebra. So what that word means that it just means a term from one side of the equation to the other. And the balancing means adding equal items on both sides. I'm going to show you what that means, but pretty simple things. And then actually, algebra actually didn't start with him. It's actually started way earlier. Is I don't know if you know about Euclid, and he wrote a book called The Element. He actually established a branch of math called geometry. And in the book, he's talking about pretty much the same thing. And he said that if equals are added to equals, then the wholes are equal. And say equals are subtracted from equals, then the remainder are equal. And you also can see the problem when we use language. Is you have to think a little, to think maybe twice and three times to understand what that means. But use algebra become pretty simple. And then in the 16th century AD, so you can see that this is 300 BC. So almost 1,000 years later, we have Al-Khwarizmi and came up, write the book about it. And then in the 16th, almost another 1,000 years later, is mathematicians in the West and pick it up and develop into a very important branch of mathematics. And so, and that time in the 16th century, this word algebra means bone setting, and just like someone's broke their bone, they put them together, kind of restoring it. And so it has some kind of, that's word, they borrowed that word algebra, then use that means a branch of math. Yeah, I hope that the little history can help you. I'm fascinated by the history of mathematics. Okay, so now we are going to talk about essence of algebra and what do they mean. When we say when talking about the balancing, so what it means just simply is this. Now, if you can see that if A is equal to B, so that means if you have two numbers, they have equal in value, two number equal in value, then you can add the same amount on both sides. So that's what means A plus C equal to B plus C. And for example, 4 is 4. If you add 3 on both sides, that's 7 on the left, 7 on the right. And that could be any number. It doesn't matter 3 or 4 or 5. You could have 4 plus 125. Then the other side, as long as you add exactly the same thing, then that is equation still true. And so that's what we come, that's one that means if A equal to B, then A plus C is B plus C. That's where Euclid means when they have the equals, then if you add equal on the equals, the sum of the equals are equal. So it's kind of mouthful when you say that using language, but in algebra, it just simply shows that if A is equal to B, then A plus C is equal to B plus C. That means you can add exactly the same amount on both sides. Then when you, and you can also subtract on both sides as long as we take out the same thing. So again, for this example, 4 equal to 4, but if you minus 1 on both sides, then that's 3 and 3, and that's still equal. And it doesn't matter what. You could, as long as the one you take out is the same, then the equation is still true. So this is kind of like the balance. That's what they call the balance is. Like the Persian mathematicians, they are part of the is the Muslim world at that time, and I mean they are dealing with trades and all that. So we do want to weigh something. Now, one thing to weigh something is have something like a balance on both sides, so it's balanced. Now, if say if we three things on both sides, they are exactly the same, then it's balanced. But if you add one more on both sides, as long as you add exactly the same thing, then it's still balanced. Or if you take out, let's say, take out 2 on both sides, then still balanced, as long as you take out the same thing. So that's actually what we mean by this first 2 here. And we also see that about multiplication. As long as we multiply exactly the same thing on both sides, then it's still true. In this case, 4 equal to 4, then if we multiply 5 on both sides, one is 20, the other one is 20, but still equal. It could multiply by 7. As long as we do the same thing on both sides, then it's 28, it's 28. That's still the same. Okay, and similarly, when we divide by the same thing, like 4 divided by 2 is equal to 4 divided by 2, as long as we divide by the same thing. Now, those seems like obvious, but many things that at the essence is simple, but when you're applying it, you can see how clever the mathematicians use those simple things to be able to solve very complicated problems. Okay, so I'm going to use just 2 simple examples. This is actually what you first they will learn when dealing with algebra. Okay, let's say Anna's age plus 3 is 15. How old is Anna? Well, if we want to write in algebra, we'll say Anna's age, we'll define that. We define our terms. That's Anna's age. Then we know that from, this is the English words, we have to translate into algebra. So translate algebra, that is a plus 3 equal to 15. So Anna's our age plus 3 is 15. Now, how do we find a? Well, remember, we said that if we take exactly the same thing on both sides, then the equation is still true. So we can take 3 out on both sides. Now, S side, we hold a left, but on the other side is 12. So therefore, we know the answer, the solution, Anna has to be 12 years old. So you can see that using that simple balancing, we can find the answer. Of course, those are pretty simple, but when you're dealing more into algebra, it can become more and more complicated problems, but the solution, you can also appreciate how clever mathematicians were and be able to solve complicated problems. Okay, another one example is this. Mark has twice as many action figures as Tom, okay? Now, Mark has 40 action figures. How many action figures does Tom have? Okay, so it's a mouthful when you using English. You use any language, but in algebra, we can say, okay, we can use M. That is action figures that Mark has. Then T is action figures Tom has. Now we're going to have defined our terms. Then we're going to translate this two sentences. Okay, so we said Mark has twice as many actions figures as Tom. So that means M is equal to 2 times T, which we write as 2T without the dot. Okay, and what we know is that Mark has 40. So we know the value of M, which is 40. Now we have these two equations now. So M is equal to 2 times T, and M is 40. That means 2 times T equal to 40. So in algebra, we just say 2T, but it means 2 times T. Well, how do we find T? Well, remember what they did earlier, that simple rule. If A is equal to B, if A is equal to B, then A divided by C is equal to B divided by C. Okay, so we're going to divide this by 2 on both sides. Well, 2 times T divided by 2, these two basically cancel each other out. So we have T left on the left, but on the right is 40 divided by 2, that's 20. So therefore, T equals 20. So that's basically the essence of arithmetic, algebra. Once you understand that, then you'll be able to learn the simple set of rules, and then with set rules, you learn how to use those. So when you actually learning algebra, is basically learning how to use those rules. Just like when you play a sports, you first has to understand the rules, and then when you're playing it, you're actually getting better at those rules until you don't even think about it. And that's where you're going to have fun when you play. Okay, I hope that this is helpful, and really appreciate if you have give me some feedbacks. And if you want, oh, I have that showed here, basically the same thing I already showed to you. And you can either contact me at pinnan.shi@gmail.com, or my number is 317-282-0744, or you can join a class with parents via Zoom, or you can join our Facebook group. It's called Math for Parents. Yeah, I hope this is helpful, and I hope you um, are interested enough or maybe brave enough to actually to learn algebra. I think you will enjoy more than back then when you first time learned it, because in most likely that uh, your teacher didn't teach you as the way I showed you, and he actually, as a grown ups now, and you actually will have a much better appreciation to use symbols, uh, to use abstractions, to to um, be able to understand, or maybe more interested in the general rules of things. That's what we would call it philosophy, or things like that. We're just trying to figure out the general rules uh, of life. All right. I hope you hope this is helpful for you, and I hope that you can join a class with other parents, or just contact me, and we can talk about it. I can, if you want to learn um, algebra, I can point to some places that you can actually learn pretty easy once you understand the essence of algebra. And I think you're enjoying it, and you find that actually it's very useful in life. Many things in life, if we know how to do algebra, that can help us to be able to find patterns to help us to solve problems. All right. Bye.